So let us begin our today's session with respect to mean value theorems. So earlier we have discussed about Rolle's mean value theorem and some of the problems based on Rolle's mean value theorem. So do you have any queries with regard to that? Problems on Rolle's mean value theorem? To anyone? Then let us take one more interesting problem on Rolle's mean value theorem. Then we take the concept of Lagrange's mean value theorem and Cauchy's mean value theorem. Now the question is, show that between any two roots of e power x cos x equal to 1, there exists at least one root of e power x sin x minus 1 equal to 0. So please take a note of this problem. It is also one of the previous year questions problem. I think it was asked earlier in UPSC. Fine. So is the question tag clear for everyone? What is given in the problem? In a simple manner, if you consider this equation, for this equation you may have so many roots, among which you consider two roots, say alpha and beta. So I have taken that alpha comma beta are roots for the equation e power x cos x equal to 1. So between these two values, I can find at least one value which is a root for this equation. Is that clear? So let us solve the same problem using Rolle's mean value theorem. Since alpha and beta are roots for the given equation, so you have e power alpha cos alpha is equal to 1 and e power beta cos beta equals to 1. Agreed? Now we are going to define a function on the interval alpha beta which satisfies the conditions of Rolle's mean value theorem. So you are going to define the function as f of x equal to e power minus x minus cos x. Let us define like this. So any doubts with regard to the definition of the function, how we are going to define? Because if you consider the given equation, if you multiply both sides with e power minus x, cos x equal to e power minus x, it is nothing but e power minus x minus cos x equal to 0. Agreed? So I have taken f of x is equal to e power minus x minus cos x. Since it is an exponential function which is continuous, it is a trigonometric function, so it is also continuous on the interval alpha beta, and they are differentiable too on the given interval alpha beta. Between the two roots alpha and beta, I trivially assumed that alpha is the small one, beta is the big one. You can take beta alpha also. Generally we write alpha beta for our notation convenience. Now if you consider f dash of x, it will be minus e power minus x plus sin x, and f satisfies all the three conditions of Rolle's mean value theorem, because if you calculate f of alpha, it is nothing but e power minus alpha minus cos alpha. So it can be written as 1 minus e power alpha into cos alpha by e power alpha, multiplying and dividing with e power alpha if you have done. Since this value is equal to 1, in the numerator you have 0 by something, so the value will be equal to 0. Agreed? So in the same manner, if we calculate f of beta, its value is also equal to 0. So you have f of alpha is equal to f of beta is satisfied. Therefore, f satisfies all the three conditions of Rolle's mean value theorem. Hence, we can apply Rolle's mean value theorem for f on the small interval alpha beta. Any more questions here for anyone? Or is that clear? Please tell. Right. Now, if we apply the Rolle's mean value theorem, there exists a value, let us say c, which is lying between alpha and beta, such that f dash of c is equal to 0. So this implies that substituting the value here, minus e power minus c plus sin c is equal to 0. So this gives that minus 1 plus e power c sin c is equal to 0. So from this we can say that the respective equation root is achieved. So c is the root of the equation e power x sin x minus 1 equal to 0. So whenever you take two roots alpha beta for this equation, between them you can find at least one root which is a root of this equation. Is the part clear? Right. So if you have noted this, then I go to the next problem. So apart from this, I want to start with Lagrange's mean value theorem. That will be interesting to everyone. After noting, please inform. So as per the assignment, with regard to real analysis is concerned, if anybody has any doubts, you please post the question numbers. I will give the respective solution. I will post the solution in Telegram group. You can cross verify that. If the assignment is clear, then we will leave. I will give the second assignment on the convergence series. Then around 30 questions I will give. So it gives the complete knowledge with regard to the infinite series concept. I hope that on solving the 30 questions, you will have a clear idea on how to solve a problem with regard to the convergence topic. So how many of you have tried? At least 50% of the assignment. So you are on the process, right? So is it hard or somewhat convenient to do? Is that hard, the assignment? After having the class sessions and the interval considered, I mean the hints considered, which are given at the end. Fine. So you go with the regular chart in the group. So whoever have the common doubts with regard to the questions, I will give the respective posters of the solution. Then I will give the second assignment on that infinite series. So 2 assignments will be good in understanding the complete concept of infinite series. That is my overall view. Thank you. So let us start with Lagrange's mean value theorem. In Rolle's mean value theorem, we are going to check for 3 conditions. If you take the function f from closed interval a b to r, we check for the continuity on closed interval a b, derivability on open interval a b, and endpoints have the equal values. So this is the strategy for Rolle's mean value theorem. Coming to Lagrange's mean value theorem, you consider the same function f from closed a b to r defined, and f satisfies the continuity property, f satisfies the derivability property. So here we are taking only 2 properties, not 3. F is continuous on closed interval AB, f is derivable on open interval AB. Now Lagrange's mean value theorem states that there exists a point C which is lying between A and B such that f dash of C is equal to f of B minus f of A by B minus A. So please take a note of that condition. After noting, you please tell. Right. Now, if you talk of the geometrical significance for Lagrange's mean value theorem, so let us take that this is the graph from A to B. Then you are going to find a point C such that f dash of C gives the tangent at the point C, and this tangent is parallel to the chord joining the points A and B. So you are going to find a tangent at the point C which is parallel to the chord joining these 2 points. Clear? That was the geometrical significance of Lagrange's mean value theorem. I think you have known this. Right. Then let us take some of the problems on this concept. Right. I will make space here. So you consider the interval 0, 1 by 2 and f from 0, 1 by 2 to r defined as f of x is equal to x into x minus 1 into x minus 2. Now we are going to verify the applicability of Lagrange's theorem over the interval. The question tag is applicability of Lagrange's mean value theorem over that interval. Okay. So if you simplify f of x, what is the value of it? Can you multiply the product and give me the polynomial? Say. X cube minus 3x square plus 2x. Am I correct? Right. Since it is a polynomial, every polynomial is continuous. Hence, it is continuous on the real line. So, in particular, it is continuous on the given interval. In exam also, we write the same content. So, if you consider the differentiation part, f dash of x is equal to 3x square minus 6x plus 2. So, f is continuous as well as differentiable on the given interval. Hence, f satisfies Lagrange's mean value theorem. Therefore, there exists C which is lying between 0 and 1 by 2 such that f dash of C is equal to f of 1 by 2 minus f of 0 by 1 by 2 minus 0. So, it gives that 3c square minus 6c plus 2 is equal to, you are going to give the values of f of 0 as well as f of 1 by 2. So, what will be the value of f of 1 by 2? Is that 3 by 8? And f of 0 is 0. Right. So, you simplify the polynomial and give me the value of C. Please do that on your part. Then we discuss about the possibility of C. So, is C is equal to 3 by 4? So, you will get a quadratic equation. You are going to evaluate its root by applying minus b plus or minus square root of b square minus 4ac by 2a. You can apply the formula if you require. So, are you doing with that? Right. So, if you give decimals by means of a calculator, it is okay. 1.76 and 0.236. Apart from this, if you consider the quadratic formula and the roots, you are going to get it as 1 plus or minus root 21 by 6. Am I correct in giving the value of C? All of you agree with this, the C value? So, for the quadratic equation, you have two possibilities, 1 plus root 21 by 6 and another one is 1 minus root 21 by 6. Since the value of C is lying within the interval, C must be bigger than 0 and smaller than half, that is 0.5. You should go with the value 0.236, nothing but 1 minus root 21 by 6 that we choose. So we neglect this value, even though we are going to get two values for C, right? So this was the conclusion of the problem. You have written that f is continuous, f is derivable, hence Lagrange's theorem is applicable. So by means of Lagrange's theorem, this would be the value of C. Okay. Any more questions on this? To anyone? Then I go with the other problem. So may I know how many of you have solved this kind of problems earlier, or you are doing for the first time? Right. Same problems or similar kind of problems? Right. So then again it will be a refreshing one for you on mean value theorems, and mean value theorems are somewhat useful in getting the inequalities and proving the deductions. So let us take some of the problems on it. So this is the problem. For 0 less than u less than v, show that v minus u by 1 plus v square is less than tan inverse v minus tan inverse u is less than v minus u by 1 plus u square. Hence, deduce that pi by 4 plus 3 by 25 is less than tan inverse 4 by 3 is less than pi by 4 plus 1 by 6. So similar kind of deductions you are going to get by means of Lagrange's mean value theorem. So have you done this problem earlier? Can you recollect? Fine. Now, while solving similar kind of problems, one interesting thing to be noted is whenever you have an inequality, so which is involving one single function, there always we use the technique of Lagrange's mean value theorem for majority of the cases to prove it. So here the function appeared to be tan inverse x. So we take that the function f of x is equal to tan inverse x on the interval u comma v, where u is less than v and both are positive. So if you go for the differentiation, f dash of x is equal to 1 by 1 plus x square. So obviously f is continuous and differentiable on the interval uv, hence you can apply the Lagrange's mean value theorem. So from that you can say that there exists a point C which is lying between u and v, such that f dash of C is equal to f of v minus f of u by v minus u. So from this we can say 1 by 1 plus c square is equal to tan inverse v minus tan inverse u by v minus u, substituting the values in it. Now I ask the question that what to do next, because you have studied this part already in calculus. Any guesses from anyone? Right. So using this inequality, C is lying between U and V. So you are going to go for the construction based on f dash of C value. So that you are going to substitute an inequality in place of 1 by 1 plus C square. Now what happens, since it is C square, you square this thing on both sides. So you will have U square is less than C square is less than V square. Since plus 1 is there, you add plus 1. So 1 plus U square is less than 1 plus C square is less than 1 plus V square. Since it is in denominator, take the reciprocal. So 1 by 1 plus U square is greater than 1 by 1 plus C square is greater than 1 by 1 plus V square. So since the values are equal here, in place of 1 by 1 plus C square, you can substitute this part in this inequality. So you are going to get it as one by 1 plus U square is less than tan inverse V minus tan inverse U by V minus U, and this is greater than 1 by 1 plus V square. Multiplying this V minus U and writing from the other end, you will have the part that this is the inequality which is going to be done. Okay. Any questions on the process to anyone who are learning for the first time? So is everyone clear with this? Okay. So after having this inequality, we are going to have a deduction here. So how the deduction takes place? In the inequality what is obtained by you, you are going to substitute suitable values in place of U and V. So as per the inputs given by U, we are going to take U is equal to 1 and V is equal to 4 by 3. Now, can you give the illustration why you are going to take that U is equal to 1 and V is equal to 4 by 3? Because 4 by 3 is evident in the inequality in the question tag, and one symbol is there, pi by 4. Tan inverse pi by 4 will be nothing but 1. So you got two numbers, one number is 1, another one is 4 by 3. If you want to choose the interval, the smaller one will be taken as U and the larger one will be taken as V. So you are going to take U is equal to 1 and V is equal to 4 by 3. Accepted? So depending upon the inequality which is given there, we are going to take the necessary values of U and V. Right. So if you substitute U is equal to 1 and V is equal to 4 by 3 in this part, you are going to get this inequality. So is this required to all to deduce, or can I leave here? As per your inputs, I will go. So if you have a doubt, I will do it right now. So please substitute the values here in this inequality and tell whether you have arrived with this or not. So by taking confirmation from you, then I will take the other problem. So what about the others? Have you finished that? Right. Now let us take the other one based on Lagrange's mean value theorem. So prove that x by 1 plus x square is less than tan inverse x, which is less than x for all x greater than 0. Now from this you tell me what is to be taken as f of x here on observing the inequality. It is nothing but tan inverse x, because its derivatives happen to be here 1 by 1 plus x square. And how to define the interval here? So whenever you have two different numbers are coming in the inequality, based on the numbers you will take the interval. So apart from this, since it is given that for all x greater than 0 you are proving, so you are going to prove the Lagrange's mean value theorem with the interval 0 comma x. So apart from taking two distinct numbers, you are considering the interval from origin to other end. So this kind of problems you can expect, right? So if you consider f dash of x, it will be 1 by 1 plus x square. F satisfies Lagrange's mean value theorem on the closed interval 0x. So you are going to obtain the formula. So f dash of c, where c is lying between 0 and x, such that f of x minus f of 0 by x minus 0. It implies that 1 by 1 plus c square equals to tan inverse x minus tan inverse 0 by x minus 0, which gives that 1 by 1 plus c square is equal to tan inverse x by x. All of you agree? Any questions? Then let us take the same inequality again here. So 0 less than c less than x, squaring on both sides. 0 less than c square less than x square. Then you have 1 less than 1 plus c square is less than 1 plus x square. Taking the reciprocal, 1 greater than 1 by 1 plus c square is greater than 1 by 1 plus x square. Substituting the value here, 1 is greater than tan inverse x by x is greater than 1 by 1 plus x square. Now multiplying with x, you will get the required inequality of the problem. Now one general question is, on seeing similar kind of inequalities, the question is what mean value theorem is going to applicable here? Do you agree? Because we are going to study three mean value theorems. On observing a particular kind of problem, what mean value theorem you are going to use here to get the solution? So for that kind of things, we can expect that since if you are talking about the roots concept, we will take Rolle's mean value theorem. If you talk of generally the inequalities and as well as increasing decreasing functions, we are going to talk about the Lagrange's mean value theorem. If there are two functions involved, in such cases we will take Cauchy's mean value theorem. Fine. The underlined idea, it is a one kind of strategy while solving the problems. Why 0 to x means, because you are going to prove the inequality for all x greater than 0, right? You are not taking the negative values. That's why interval will be taken from 0 to x. X will be sufficiently large. You are not going to take infinity, right? That's why you take sufficiently large x, because you are saying that on the number line, you start here, you can take x at any part. X is sufficiently large. That much big interval you are going to take. Any other doubts from anybody with regard to this question? If you have any other queries, you can ask. Then I am going to discuss about Cauchy's mean value theorem. Then we come back with some other problems based on these mean value theorem concepts. And possibly I will give around 10 problems for a rough practice with regard to mean value theorems for you. That will be sufficient. So let us discuss about Cauchy's mean value theorem. Suppose if you have considered two functions on the same interval, f from closed AB to R and g from closed AB to R, with the property that f comma g both are continuous on closed interval AB and f comma g both are derivable on open interval AB. Another part is derivative of g is not equal to 0 for all x belongs to AB. If the three conditions are satisfied by the functions f and g, then Cauchy's mean value theorem states that you are going to find a point C which is lying between A and B such that f dash of C by g dash of C is equal to f of B minus f of A by g of B minus g of A. That was the condition. So please take a note of this condition. I think you also come across for this problem earlier. Problems based on Cauchy's mean value theorem. Then let us take two problems on it that gives a rough idea or a refreshment for you on this concept. Fine. Shall I continue? So any more doubts with regard to the statement considered? It is just like a formula, because we are not going to discuss about the theory, how the derivation comes, because the derivation is generally not given in the problem. Right. So while proving the continuity and differentiability of the functions in the problem, we straight away mentioned that the function is continuous, the function is differentiable, but we won't check for the continuity and differentiability, because we assume that the functions are continuous and defined on the given interval. Whenever we have a doubt, at that point only we check for the applicability. Otherwise, always Cauchy's mean value theorem is applicable on the functions which are given there. So we are considering the problems which are not the failure cases, which hold the data of the theorem. So you take that on closed interval 1 comma 2, f of x is equal to x square g of x is equal to x cube. Now you check for the applicability of Cauchy's mean value theorem and let us find the value of c from that. Okay, since both are polynomial functions, one thing is x square, another one is x cube. They are continuous on the real line as well as on the given closure interval 1, 2. And also they are differentiable because if you consider f dash of x, it will be 2x and it will be 3x square for g. And they are differentiable and g dash of x is not equal to 0 in the given interval. On the open interval 1, 2. So hence we can apply Cauchy's mean value theorem. So there exists a point C which is lying between 1 and 2 such that f dash of c by g dash of c is equal to f of 2 minus f of 1 by g of 2 minus g of 1, which gives that 2c by 3c square is equal to, you are going to substitute the values. So you give me the value of c here from this. So you got two values for c or only one value for c here? One value, that is 14 by 9, right? So please take a note of it. Is everyone clear with this problem? Then I'll go for the other problem. Now the other one is show that sin alpha minus sin beta by cos beta minus cos alpha equals to cot theta, where 0 less than, alpha less than, theta less than, beta less than pi by 2. I think it is also one of the previous year question problems. So if you have seen this immediately, if you talk of trigonometric properties, it is somewhat difficult to assume what trigonometric properties you are going to apply here. Apart from this, if you visualize that sine and cos are two different functions which are given in a fraction, since in the numerator the sine function is dominant and the denominator cos function is dominant, so we have a thought that can we apply Cauchy's mean value theorem there? It's a thing. If you don't study Cauchy's mean value theorem, on seeing it we may use the properties which you have learned at calculus and trigonometry. Otherwise, if you have studied Cauchy's mean value theorem, then you can just think of it whether it is applicable here or not. So if that is so, what is the interval to be taken here as per the limit specified there? Can you tell? 0 less than, alpha less than, theta less than, beta less than pi by 2. Actually, the functions are given in terms of alpha beta, right? So the interval you are going to take it as alpha beta, and theta is lying in between them. Since alpha beta you can take any numbers, you cannot exceed 0 and pi by 2. So alpha beta values are lying in between 0 and pi by 2. Clear? So we won't consider 0 pi by 2, we consider alpha beta. Then only this type of fraction will come. So we're going to take f of x is equal to sin x, g of x is equal to cos x. As per the numerator and denominator are considered. So if you consider the derivatives, f dash of x is equal to cos x, g dash of x is equal to minus sin x. So you are going to get theta, which is lying between alpha and beta, as per Cauchy's mean value theorem, such that f dash of theta by g dash of theta is equal to f of beta minus f of alpha by g of beta minus g of alpha. So if you substitute the respective values there, it will be cos theta by minus sin theta equals to sin beta minus sin alpha by cos beta minus cos alpha. So from this you are going to get this value by multiplying with minus, and cos by sin is giving that cot. Okay. So here in choosing the interval is one interesting issue while doing problems on mean value theorems. What interval we are going to choose? Clear? Any more questions over this problem? To anyone? Or is it clear? The proof of Cauchy's mean value theorem is taken from Lagrange's mean value theorem. Yes, trick is given in choosing the interval. That is also very clear because the values are given in terms of alpha and beta, right? So interval will be obviously alpha and beta. If you get some fraction or number there, then you are going to choose for 0 and pi by 2. It is very evident that, because if it is simply mentioned alpha and beta, for example, let me say you have excluded these two parts. It is simply given that prove this thing where alpha less than theta less than beta. Right. Now obviously you choose the interval as alpha beta, right? So if you take alpha as 0 and beta as pi by 2, then what happens? By considering the values there, similarly, if you take another values like pi, 3 pi, you can take sufficiently large values in place of alpha and beta, right? So in some situations you will have the possibility of getting undefined. So to avoid that, he has given certain limits. Alpha and beta cannot exceed this thought. That's it. Okay. Because this thing is not always true for all values of alpha and beta. There may be some violations. For this, he has given the upper and lower boundaries for alpha and beta. Now, so can I take the guarantee that you have studied these mean value theorems earlier in calculus chapter? All of you? Because I don't want to take much more examples on mean value theorems because you have studied, it will be a repetition for you. So it is a waste of time to consider the same problems one more time. So I will give a practice for you, you can do the practice. The problems related to mean value theorems. Is it agreeable? right? Then I start a simple topic. Then we conclude the discussion on this mean value theorems concept and differentiability, and we go with the concept of Riemann integrability, which is very interesting and important with regard to UPSC. Many of the questions are asked on it. So that will be our upcoming session. Now I am going to discuss the part with increasing and decreasing functions. Right? Now, suppose we have taken a function from S to R, or you can take a closed interval AB to R. We say that the function is increasing whenever you take 2 points x1 and x2 such that x1 is less than x2, then corresponding images f of x1 is less than or equal to f of x2. We call it as an increasing function, or you can say monotonically increasing. So a simple example is you take f of x is equal to x square on the number line. So whenever you take 2 less than 3, f of 2 is less than or equal to f of 3. Agreed? So whenever f satisfies that kind of property, we call it as f as an increasing function. In particular, if x1 is less than x2, then f of x1 is strictly less than f of x2, then we say that f is strictly increasing function. Similarly, we define the decreasing function as whenever x1 less than x2, f of x1 must be greater than or equal to f of x2. You take the case of 1 by x square. So whenever 2 less than 3, so 1 by 2 square is greater than or equal to 1 by 3 square. Agreed? I think this definition is known to you. Increasing and decreasing functions. Yes or no? Right. Now, what is the interconnectivity for the differentiation of f and increasing, decreasing? Can you tell? Any guesses? The thing is, if we calculate the derivative f dash of x, if it is greater than 0, then what we can say? F is increasing, right? So if you calculate the derivative, if it is less than 0, then we say that f is decreasing. Agreed? Now, let us do some problems based on this concept. So to know the nature of the function, whether it is increasing or decreasing, you are calculating the derivative. If f dash of x is positive, it is increasing. F dash of x is less than 0, it is decreasing. Okay? So let us take some of the problems on it. I think this point is known to you. Otherwise, you please take a note of it. So for increasing, it must be greater than 0. For decreasing, it must be less than 0. Fine. This is the inequality we are going to prove. So x minus x square by 2 is less than log of 1 plus x is less than x minus x square by 2 into 1 plus x. Now what happens, since it is in the form of inequality, you can think about the Lagrange's mean value theorem. You have a possibility. Sometimes for this kind of inequalities, Lagrange's theorem holds good. Otherwise, we use the concept of increasing and decreasing functions in establishing the inequalities. Now, if you understand that there are two inequalities we are going to prove, this part is less than this and this part is less than this. So what happens? I am going to define a function as f of x is equal to log of 1 plus x minus of x minus x square by 2. Why I am defining this? Because I am going to prove that this is less than this. And the interval is obviously 0, x. Because you are going to prove the inequality for all x greater than 0. Now what I am going to do? I am going to calculate f dash of x. So it will be 1 by 1 plus x minus of 1 minus x. So can you go for the LCM and give me the result? I will say that if you go for the LCM, you are going to get it as the value x square by 1 plus x. Can you check on that? Right. Since you are taking x as positive, so the result is nothing but positive. So, since the derivative is greater than 0, we can say that it is an increasing function. So, if you apply the condition of increasing function, so from the interval, the starting point is the smallest one, ending point is the biggest one. So, you have 0 is less than x. So f of 0 is less than or equal to f of x, strictly less than here. So this implies if you substitute 0 here, so f of 0, if you consider log 1, it will be 0 and it will be 0. So 0 is less than log of 1 plus x minus of x minus x square by 2. So this gives that, taking this here to the left, accept it all. So what we are doing, the underlined idea, the total inequality is bifurcated into two parts. For each part you are getting an inequality and you are combining them. So for each part you are defining a function here. So if you take the other one, now how to define the function there? So can I erase this? Right. Now for the second part, I will define the function as you take g of x is equal to x minus x square by 2 into 1 plus x minus of log of 1 plus x. Why I have taken the function? Because as per the inequality is considered, this is the bigger one, this is the smaller one. So I am defining big one minus small one, because if I consider derivative, it must be greater than 0. Okay. In the other way around also you can define log of 1 plus x minus of the part. That is also you can do. Is it clear to all? So can you go for the differentiation part of it? So I will say that on simplification, you are going to get it as x square by 2 into 1 plus x square whole square. Please check on that. So after having the result, you please inform me. If you feel any difficulty, you can tell in getting the derivative value. So if everyone finished, then I will continue in calculating g dash of x. Right? So since you are taking x as positive, this value is positive. Accepted? Therefore, g is an increasing function. So we have for 0 less than x, g of 0 is less than g of x. Hence, g of 0 is nothing but 0. 0 is less than x minus x square by 2 into 1 plus x minus of log of 1 plus x, which gives that log of 1 plus x is less than x minus x square by 2 into 1 plus x. So this was the whole idea in proving the inequalities. Okay? Right. Then I just want to take one interesting inequality. Then I will conclude our today's session. So can I continue? So is it difficult or easy in understanding the concept of inequalities? Fine. Occasionally you will get some inequalities which are difficult to solve. In other words, simplification part, not the conceptual part. Conceptual part is always easy. So this is the problem that for 0 less than x less than pi by 2, you are going to prove that tan x by x is greater than x by sin x. This was the problem. I think it is also one of the previous year questions. Right. Now, the approach here is nothing but, since you are going to prove that, let us take the difference between the two values. First, forget about the interval. Consider the difference between two fractions. So if you have proved that this is positive, automatically this fraction will be greater than this fraction. Agreed? Yes or no? Right. Now, if you consider the LCM here, it will be x into sin x, and in the numerator you are going to get it as tan x into sin x minus x square. Since this part is positive, automatically, to show that this is greater than 0, this part I need to show this is greater than 0, the numerator part. If I have proved that the numerator tan x into sin x minus x square is greater than 0, automatically you have achieved the required inequality. Accepted? So it must be true for the given interval 0 comma pi by 2. Now, since you are taking x which is less than pi by 2, so I will take the interval as 0 comma c, where c is belonging to the interval, and you take f of x is equal to tan x into sin x minus x square. Is it clear? Yes or no? Right. Now, how to prove that it is greater than 0? Nothing but I am going to take the derivative. F dash of x. So I need to prove that f dash of x is greater than 0, then it becomes increasing. F will be the increasing function. Now, here I am going to consider the two derivatives, f dash and the other derivative f double dash. Right? So first of all, if you take f of x is equal to tan x into sin x minus x square, let us go with the derivative part. So if we calculate f dash of x, it will be tan x into cos x plus sin x into secant square x minus 2x. Agreed? Right. Now you can simplify the part also. You can take sin x as common. Here you will get sin x as, so 1 plus this is the part remained with me, sin x into 1 plus secant square x minus 2x. Now again go with the differentiation here. I am going to take the double differentiation. So let us give a name as, if you take g is equal to f dash of x, it will be g dash, f double dash of x. So if you calculate the value, you are going to get it as cos x into 1 plus secant square x plus sin x into 2 secant x into tan x minus 2. 2 seconds per x. Right. So you can simplify the parts there. Now, how to simplify the part here? How to simplify the part here? Any guesses from anyone in the simplification part? So this part we can write it as hence you are going to find it as, I can say, so do you agree for this value? Please tell. If we expand it by means of a minus b whole square formula, is that right? Okay. All my intention is nothing but I just want to prove that the value should be positive. So if the value is positive, then f dash will be increasing function. Since this is increasing function, automatically this will be positive. That is the whole idea in calculating the derivatives. Therefore, the numerator is positive, hence the required inequality is obtained. That was the summary, the approach so far considered. Right. Okay. So this is about the inequality. So let us wind up our session here, and tomorrow we will meet with other concepts. So if you have any other queries, you can ask. All of you agree for that approach? Fine. Right? So then we will meet tomorrow with new concepts. And let us wind up our session here.